The next tool is to address the level of certainty analysis for indirect conclusions. For indirect conclusions, we're asking, how do we know if these indirect conclusions are true? That is, how do we trust the meanings drawn from the data, not the data themselves, but the meanings that they're trying to for them? So to address the level of certainty of indirect conclusions, where we're extrapolating to a more significant something, the first thing we have to consider is that maybe the direct conclusions were wrong. So we need to address what direct conclusions the indirect ones were built on and analyze their level of certainty as we just did before this. Note that if something is based on multiple direct conclusions, we need to ask a question. Well, if we had these conclusions, can any of them be right to bring our conclusions? That is, they were increasing our level of certainty by adding additional evidence, in which case we really worry about the most certain of them, not the least certain, and all of the other ones add to certainty even if they're uncertain. Or do we really need each one to be true? So we string together in series these logical arguments, and only if they're all valid do we get to our final conclusion, in which case it's the weakest of the arguments that determine the level of certainty. So in addition to addressing the level of certainty of the direct conclusions, we want to look at what are alternatives that you might consider to the indirect conclusion being true. So perhaps the direct conclusion is true, but the indirect isn't, and try to understand then how. So first we're asking what those alternatives could be, and then if there's alternatives you think of, are they contradicted with additional experiments, logical arguments, calculations, observations from the literature, etc. And if these key alternatives are not eliminated, then the indirect conclusions are still worth mentioning, but they should use a low level of certainty when they describe them so that the reader understands that they can't draw those conclusions from this paper. They can't rely on those conclusions. They're just suggested conclusions that might provide insights about new directions to go. So how do we identify alternatives? So one thing very simple is to consider that the opposite is true. So if the conclusion isn't true, the opposite would be true, and then said, well, gosh, how could that be true and the direct conclusion still be right? Be creative, come up with ideas. Also look at where the authors have done it, but what's great is to come up with your own. This is also a great way, all of this stuff, to manage your own research or design project. So an indirect conclusion here, again, from the Elias paper, and I will mention, I should have said this before, I should have put this here. This is a quote here of theirs. Because there's only one article that I'm quoting here, I don't have to repeat the citation each time because it's implicit. But if I had even 2 articles, I would have to give this citation each time I put a quote. So the conclusion here is, in comparison with the scaffolds, the brain was observed to relax both significantly faster and to a much lower final force relative to its peak load. In considering the various scaffolds used for central nervous system tissue engineering applications, it appears the scaffolds of 1% or lower collagen concentrations are potential candidates for implantation in the brain. Okay, so we stop here. This first part in green is just a reiteration of the direct conclusion. So of course we have to consider that could be wrong. We'd have to go back and interpret that. We won't do that in this exercise now because we've already done it, illustrated that skill. Then the second thing is maybe the scaffolds are not appropriate for implantation in the brain because the thing here said that the 1% or lower scaffolds would be potential candidates. So I'm just saying this is the opposite of that. They're not potential candidates. So then we ask, well, why might they not be? So one possibility is maybe the stiffness shouldn't be less. And in fact, they're arguing that these ones are appropriate because their stiffness is similar or less than the brain, so they would be safe to implant and suitable for neuronal support. So they give us some hints here, right? Well, maybe the stiffness doesn't need to be less. Maybe for some reason that's not ideal. I think they made some arguments with the literature to that extent in this, but you'd want to address that. But then also, well, okay, what if the fast relaxation is not the key property? So they've just cited up here these differences, and then they've proceeded to ignore them. So maybe that's a mistake. Maybe the fact fast relaxation is important, or the larger degree of relaxation, where compared to peak force, the scaffolds only relax a little, the brain relaxes a lot. Maybe that's really important. So also when they say things like it's suitable for neuronal support, well, what is important for neuronal support? Maybe the non-mechanical behaviors, in fact, are important. So these are examples of alternatives. We consider maybe the viscous are important, and or maybe the non-mechanical. And if these aren't addressed, then this would have then a very low level of certainty. If they are addressed, it might be higher. So this is an illustration then of how to analyze the level of certainty of direct and indirect conclusions.